Hello everyone, so today we're going to be working on 9.2 rate of change within tables. So one thing that I want to make sure you're aware of that this will probably more than likely be the last unit of the semester. There's going to be more information to come about what next week is going to look like, especially that test that can be used to replace your lowest test score. So keep a lookout on that to make sure that you are aware and are prepared for when you have to take that test or when you choose to take that test if you do. So again, today is going to be rate of change. Before we start diving into rate of change, I want to do two entry test problems. I want to see them in your notes. The main reason is because I want to pretty much build a foundation that when we get to rate of change, you'll notice that you're not doing anything different. You're doing the exact same thing, except now you're putting a little context behind it. So I gave you two tables. I want you to find the slope. Remember that slope is literally just a way to measure the steepness of a graph. How do we find slope? Well, we find it by finding the change in y. Let me erase it because it glitched on me a little bit. Finding the change in y and then dividing it by the change of x. Now remember that when you have that in a graph, if you have a graph, you're going to have some type of line, and you're going to look for the coordinate points. You're going to look for two specific coordinate points. Notice that I drew multiple of them. You're going to choose multiple points, and then you're going to see, okay, how much did I go up or down? You're going to divide it by how much left or right you went. Very straightforward. We practiced this the last couple of days. So one thing that I want you to notice is you're not doing anything different when you're dealing with tables, because those tables are just values for each and one of these coordinate points. 2, 3 is a point. -1 is a point. 0, 1 is another point on a line. Of course, it's not represented in a line, but it's your job to pretty much find the slope of this table. That's pretty much it. So let's go ahead and do that. Again, when you are graphing or when you are finding the slope of a line, what do we need? We need 2 points, and then we need to find the difference. Now notice here that I have multiple points. So all you have to do is choose 2. And just like a line, my biggest suggestion is to choose 2 points that are closest to each other, because there's less reducing. Your fraction's not going to be as big, etc., etc., etc. So let's choose 2 points. I always analyze my points, and I kind of choose my x's that are smaller. So I'm looking down this, my x's, and which 2 points do I want to choose? Well, 0 seems pretty small. I'm going to choose 1 as well, because -1, negatives can get kind of scary. So here are my 2 points. What I've noticed some students do is that they literally take the points, write 2 ordered pairs, and then just use their formula. Remember that when you have 2 ordered pairs, in order to find the slope, you need to find the difference in the y's divided by the difference of the x's. Remember that this was the first x and y that I wrote down. This is the second x and y that I wrote down. So y2 minus y1. Let me write down that formula so that way, if you're forgetting about it, I know as soon as I write it down, I'll click all of a sudden. You'll be like, oh yeah, that formula that we practiced. So all we have to do is fill in the spots. Remember, change in y, you find the difference in your y's. Change of x, you find the difference in your x's. So y2 in this situation is 3, y1 is 1, x2 is 1, and x1 is 0. Now you just got to do the math. 3 minus 1 is not 3, it is 2. 1 minus 0 is 1. Remember, I want you to reduce. So if you have 2 divided by 1, remember that 2 divided by 1 is 2, so your slope is 2. If you were to graph all these points, this graph would be going up 2 over 1, up 2 over 1. That is something what the graph would look like. And that's pretty much it. You're doing the exact same thing over and over and over. Now, some students like to write down their 2 points, and then that's pretty much it. They like doing all this step here. There's another quick way of doing it that I don't mind you guys doing. But it's really important that you make sure that you don't do the kind of tricky. I'll erase this so that way we have a little more space. And write it a little bit smaller. I don't know how much that'll help, but it helped. So remember that whenever you're finding slope, you're finding the ratio between the changes in the y divided by the changes of the x's. So if you look at these y's, in order to find the change, you don't necessarily have to pull out the ordered pairs. Choose two numbers that are close to each other. I'm looking down this list. I always kind of gravitate to the smaller numbers that are closer to each other. So in my head, 0 and 4 are standing out a little bit more, and then 4 and 2 are also now does it mean you have to choose these? No, and I'll probably do an example to show you in a second. So in order to find the difference in the y's, you're literally just finding the change. So how do I get from 4 to 2? Well, mathematically, I have to subtract 2. How do I go from 0 to 4? Well, I have to add 4. Super important that when you're finding the differences, you're subtracting the same y's with the same x's in terms of, hey, I'm taking the top number and then I'm saying, how do I get to the bottom? I'm saying, I'm at the top number, how do I get to the bottom? Because if you mix these and go backwards, your signs are going to be all messed up. Make sure you're going the same direction. And now it's quite easy because the change in y is a -2, the change of x is a +4. Therefore, your slope, which is the change in y, -2, divided by your change of x is -2/4. Remember, you always have to reduce these. A negative divided by a positive is a negative, so you know it's going to be a negative. 1 divides the top and the bottom equally, that's not 1. It'd be a 2. 2 divided by 2 is 1. 4 divided by 2 is 2. So your slope is -1/2. You know that this would be going down. You'd be going down 1, going to the right 2 units. So that is pretty much how you find the slope of a table. Is pretty much the exact same thing you did. It's even a little easier because you can just really see, okay, what is that change? How do I get from 4 to 2? How do I get from 0 to 4, etc., etc. So I'm going to erase this. Make sure you include it in your guys' notes because now we're going to pull it all together. Now, before we pull all this stuff together, we need to know what rate of change is. Now, rate of change is a very simple subject. You technically have been doing this this whole unit. A rate of change is the ratio in the change of y, which is known as the dependent variable, to the change of x, known as the independent variable. So we're literally doing the same thing here. We're finding the change of y divided by the change of x, but now we're putting a little bit of context, aka story problems. Remember that the change in y is going to be considered the dependent variable, and the change in x is the independent variable. So what we're really doing is, again, doing the same thing over, but we're adding context. Now, what I want you guys to do is think about some rates of changes. When something changes, this changes in this amount each time. What are the more famous ones that you guys could probably think of? I know the ones that I think of a lot are miles per hour. So notice here that you have miles per hour. Now let me write that as a fraction over another fraction. Numerator and denominator more clearly on top of each other is what I try to say. Miles an hour. So notice that here, your miles would be the dependent variable because it depends on how much miles it goes, how much hours you're going. Hours is your independent variable because it doesn't really matter how much miles you go. Miles is dependent on how much hours you are going. And the hours you go, it depends on what you believe, how much you want to drive. So notice here again that you're doing the same thing. You're doing exactly what you were doing, except you're putting a little context to it. So what's some other more famous ones? I can't think of any, but if you write them down, I'll give you an extra point or something. Of course, it can't be miles per hour. Usually it's dollars per hour, how much someone earns. I think that's a very popular one. All right, so before we get to that, notice we should notice that picture. That really rate of change is just the slope, except we're putting context behind it. And since there's context, we're kind of changing the name because there's actually units involved. So if I tell you to find the rate of change of the following, rate of change, again, is the change in y over the change of x. Y is known as the dependent variable, and x is known as the independent variable. So if I'm looking at this number 3 and 4, and it's my job to find the rate of change, there's going to be no trickery. Your x's are always going to go first in the table, just like they always have. Y is going to go second. So you can kind of use it as a rule of thumb that whatever's in the x column is the independent variable, and then whatever's in the y is your dependent variable, which makes absolute sense because if you have a number of raffle tickets, and this is the cost of the raffle tickets in dollar, the cost is going to depend on how much you have. So one is dependent on the other, and the other one's independent because it really depends on what happens. So in order to find the rate of change, again, change of y over change of x. Let's figure out the change of y. Which of these two numbers looks pretty easy? They all look pretty straightforward, so I'm just going to choose the ones in the middle. Looking at that a second, I probably would have chose the first two because they're the smallest, but again, it doesn't matter. Now, how do I go from 2 to 4, aka what is the rate of change? What changed? Well, I added 2. How do I go from 4 to 8? Well, I added 4. So notice that my rate of change, I'm going to call it my rock, just to shorten things up, is the change in y, or the change of dependent variables, which in this situation is a 2, divided by the change of x, or my independent variables, which is 4. If I were to reduce this, I could divide it by 2 over 2, which equals 1 over 2. Because 2 divided by 2 is 1, 4 divided by 2 is 2. So we end up with 1/2. Now, I just don't want you to find the number. I want you to find the units. So, for instance, the easiest way I like to do this is like, okay, I'm dividing 1 by 2. I'm dividing my y's over my x's. Now, what do our y's stand for? Let me erase this to make sure we're able to read it. Notice that it's the total cost of raffle tickets in dollars. So that means that I have $1/2 per every x, because I divided on one of my x's the number of raffle tickets. So it is literally dollars per raffle ticket. That's your rate of change. Every time you add $1, you're getting 2 raffle tickets. Okay. All right. Next one, really quick, so that way we can go. So you're asking me to find the rate of change. Well, I know I need to divide the change in y over change of x. I could go ahead and already get my units done, because I know that in order to find my rate of change is change of y over change of x. My y's, again, are the total cost of photos. I wouldn't put total cost, I would put, again, dollars. You can shorten it up with the $sign. And the number of photos printed. Now, what are we talking about? We're talking about photos. So when I find this ratio, I'm finding the dollars per each photo. Now I have to go ahead and do that. Now, the first two seem like the smallest, so to get from 2 to 4, I'm adding 2. 10 to 20, I'm adding 10. So that means that my rate of change is the change in y over change of x, 2 over 10. Let's reduce this by dividing by 2 on the top and the bottom. I end up with 1 over 5. What does this represent? Dollars per photo. All right, so 2 more examples and we'll call it a day. Now this is where you get to make up the situation, or you get to analyze the situation and make up your table by yourself. So 2 things I want you to do: fill out the table, make sure you're finding the rate of change. So Margot went to the lumberyard to buy supplies. She knows she will have to buy several pieces of wood. Each piece of wood costs $3. So again, notice that you have wood, you have dollars. Which one depends on which one? If you go to the store, do they really set a limit on how much you spend? No, that's independent. You can go to the store with whatever you want. The number of wood is what you choose. So I know that whenever you set up your table, it's always, again, your x value, which is the independent, and then your dependent is whatever goes, whatever is dependent, right? The cost is going to depend on how much wood. Now, what is the least amount of wood? And it doesn't really matter what you choose, as long as you're sequential in what you choose. For instance, if you say, like, okay, I'm going to buy 0 pieces of wood, I'm just going to go to see stuff. You have to go, okay, 1 and 2, just to increase the number of wood that you buy. So if you buy 0 wood, you get 0 cost. If you buy 1, you get 3. If you buy 2, you get 6 cost. So you can see that this is how you fill in your table. The hardest part is figuring out what your x and your y value, aka your independent and dependent. Now let's figure out the rate of change. So 0 to 3, you have to add 3. 0 to 1, you have to add 1. So let's figure out our rate of change. It's going to be our change in y, which is 3, over my change of x, which is 1. So 3 divided by 1 is 3. And then remember that you have to have your units. Easiest way I like to do it is look at your guys' table, because it's going to have what each one of these numbers. Your y's means cost. So you can write down cost, you can write a $sign, anything that lets me know you're talking about money. What are we talking about on the x? We're talking about wood. So what does this represent? It represents the cost per each wood. $3 is what costs. So you'll notice that is exactly what we agree with on top. All right, so I'm going to erase this so that way I have room to do the other one. So Margot's going to work now for a carpenter. Each week she will earn $10 plus $2 an hour. So what is going on here? She's going to work for a certain amount of hours, and then she's going to get paid. So that means that we're going to have hours on our left, and we're going to have money or dollar signs on the right, pretty much how much money she's earning. Now let's say she works 0 hours. Well, she's gonna still earn $10 because she's getting charged or she's getting paid $10. Let's say she works 1 and then 2 hours, and you can see that's gonna go up by 2 each time. Now you can see that the rate of change is kind of straightforward. You notice that you're adding 2 in the money for each hour that you add. So that means that your slope is 2 over 1. Reduce it, it equals 2. What does this represent? The cost divided by the hours. How much money you're earning for each hour. So that's pretty much it. I am not going to assign any homework. I know today was kind of a weird day. Just turn in these notes. No homework. We're just gonna go from there. Okay.